What if you flew to the edge of the universe and hit a wall? A final, absolute barrier where space itself just stops. It's a terrifying thought. And for years, it's been the one question that haunts us more than any other. The universe is expanding. We know this. It exploded into being 14 billion years ago. But anything that expands must have a boundary, right? An outer rim. So there must be an edge. And there is. But it is not a wall. It is something far stranger. Information can only travel at the speed of light. It's the cosmic speed limit. This means we can only see the parts of the universe whose light has had enough time to reach our eyes over the last 14 billion years. As we peer out into the darkness, we are staring into a bubble, a vast sphere of light with us, right at the center. This is the observable universe. But here's the first twist. Because space has been stretching the whole time, the most distant things we see are not 14 billion light years away. They are now 45 billion light years away. So our cage is a sphere with a radius of 45 billion light years. Inside it, 200 billion galaxies swirl, each holding hundreds of billions of stars. It is impossibly vast. But it has an edge. For us, that edge is an edge in time. When we look to the farthest reaches, we are looking so far back into the past that there is no more past left to see. We are staring at the dawn of time itself, a shimmering wall of primordial fire. But that's just the edge of what we can see. The real universe, the total universe, is certainly bigger. The question is, how much bigger? And this is where reality splits in two. There are only two possibilities. Either the universe is gigantic but finite, or it is truly mind-shatteringly infinite. Let's start with finite. A finite universe means that, if you wanted to, you could fill it with a finite amount of ice cream. It would be a galaxy-choking amount of ice cream, but the number wouldn't go on forever. This idea creates a horrible problem. A finite thing has an edge, a cosmic wall where space ends. But what's on the other side? By definition, the universe is all there is. The concept of something being outside of everything melts the human brain. It's a logical impossibility, except there's a physics hack, a way to have a universe that is finite, but has no border. Imagine you are a tiny ant on the skin of an orange. To you, the orange peel looks flat and stretches on forever. You can only see your immediate patch of orange skin. But if you start walking in a straight line, you will not fall off an edge. You will eventually circle the entire orange and arrive right back where you started. The skin of an orange is finite, but it has no border. Our universe is not an orange peel, but it could be a hypersphere. Our three-dimensional space could be curled back on itself, just like the two-dimensional surface of that orange. It's impossible to visualize. Our minds aren't built for it. But the logic holds. No borders, no outside. The whole of 3D space is the peel. If you boarded a spaceship and flew in a perfectly straight line, you would never hit a wall. You would, after an unimaginable journey, see Earth appearing in your viewport once again. How could this even work? It comes down to gravity. Mass bends space-time. This bending is strongest near a star or a galaxy, but a tiny bit of that tension stretches across the entire fabric of reality. If there is enough mass and energy in the universe, that collective tension could bend the whole of space-time back onto itself, creating the hypersphere. If this is true, how big is it? On Earth, we can calculate the planet's size by watching ships disappear over the horizon. Scientists have tried to find a similar universe horizon, a large-scale curvature in the cosmos. They have found nothing. The universe appears perfectly flat. For that to be true, a hyperspherical universe would have to be so colossal that from our tiny ant-like perspective, we can't detect the curve. It would need to be at least 1,000 times bigger than the part we can see. It could be 1,000,000,000,000 times bigger. We simply don't know. But some scientists felt that was too simple. They came up with a wilder shape. The universe might not be a sphere. It might be like the frosting on a donut, a hyperdonut. Again, don't try to picture it. Just know this: it's also finite and has no borders. Flying in a straight line would still bring you back home, but with bizarre complications. In a hyperdonut universe, the distance around the cosmic donut is different depending on which way you go. Two spaceships leaving Earth in different directions could return at vastly different times. One might take a cosmic shortcut through the hole of the donut, while the other takes the long way around the outside. This twisted geometry would create a cosmic hall of mirrors. Light from distant galaxies would take multiple paths to reach us. We could see the same galaxy in two different places in the sky, but it gets stranger. Not only would we see it in two places, we would see it at two different times, because the light would have traveled for different durations along each path. You could be looking straight ahead and see a star being born, and in the exact opposite direction, across the dark canvas of space, you would see the light from that very same star as it dies. A ghost and a newborn from the same source, visible at the same time. How big would this cosmic donut be? Its strange shape means it could actually be one of the smallest possible universes, perhaps only a few times bigger than our observable bubble. Or it could be trillions of times larger. Again, we have no idea. That covers the strange, looping, finite possibilities. But what if the truth is the other option? What if the universe is not finite at all? What if it is truly, literally infinite? The standard model of cosmology, the one most scientists use for their calculations, actually describes an infinite universe. We use it to understand what happens inside our observable patch, but if you take its equations to their logical conclusion, they predict that space goes on forever. An infinite universe has no border. It has no shape. It just is forever, in every direction. This idea doesn't just bend the brain, it shatters it. First, if the universe is infinite, was it always there? Did it have a beginning? All our evidence points to the Big Bang. It seems our universe did start at a specific point in the past. So how could nothing everywhere suddenly become an infinite something everywhere? Welcome to the paradoxes of infinity. And it gets worse. We know the universe is expanding. The distance between galaxies is growing. How can an infinite thing, which is already everywhere, get bigger? It just does. Infinite space can still stretch. But the true weirdness of infinity is yet to come. It leads to the most personal and unsettling conclusion in all of science. Imagine you are back in your spaceship, traveling in a straight line forever. You pass endless new galaxies, new stars, new planets. You see wonders beyond imagination. Life forms stranger than fiction. But after a journey so long it loses all meaning, you might find the single most remarkable thing in the entire universe. You, an exact copy of you, living on an exact copy of Earth, in an exact copy of our solar system. How is this possible? Because everything you are, everything you see, is made of a finite number of particle types. Protons, neutrons, electrons. And these finite building blocks can only be combined in a finite number of ways. The number of combinations is staggering. It's a number so large your brain would register it as infinite. But it is not. It is finite. So you have a finite set of possible things. But you have an infinite amount of space for those things to exist in. If you have an infinite number of lottery tickets, it is not just possible you will win. It is a statistical certainty. Somewhere out there, in that endless darkness, the laws of physics are the same. Clouds of gas collapse to form stars and planets. On one of them, chemistry gave rise to primitive genetic code. Cells emerged. Animals evolved. And against all odds, a species of ape learn to build tools, and wonder about the stars. It happened here at least once, so the probability is not zero. And in an infinite universe, any event with a non-zero probability must happen, not just once, but an infinite number of times. There is a copy of you out there, and another, an infinite number of yous. Some are making the exact same choices as you are right now. Others made a different choice a second ago, and their lives are now branching away from yours. There is a version of you who is a celebrated hero, another who is a wanted criminal. Every possible life you could have lived is being lived right now by a copy of you somewhere in the infinite expanse. But here's the final brutal twist. You will never meet them, because the odds of your specific arrangement of atoms coming together are almost zero. And almost zero in an infinite universe means you have to travel an almost infinite distance to find it. The estimated distance to your nearest identical Earth, your nearest identical you, is a number so vast it defies notation. It's 10 to the power of 10 to the power of 29 times the size of our observable universe. A 1 followed by 100 octillion zeros. It is a distance so great that it is, for all practical purposes, forever. We have now left the realm of science and entered philosophy. None of these ideas, the hypersphere, the hyperdonut, the infinite copies of you, are testable. We are apes on a small rock, staring at a sliver of light, guessing at the nature of a reality that may be fundamentally beyond our grasp. If the universe is truly infinite, we can never, ever know. The truth is, for you and for me, the universe is finite, and it does have an edge. It is the only edge we will ever see. The edge in time. Everything we can ever touch, ever influence, ever know, is trapped inside our bubble of observation. And that will likely stay true for all of time. The secrets beyond that shimmering wall of light from the dawn of creation will remain secrets forever.